What is the green area? Line constructions, area of a sector, area of a right triangle and sine rule are used to solve this question. The figure shows that each side of the inscribed triangle is bisected. Label points O, B, C, D, and E. Join line OB, line OC, and line OE. Since line OE is a bisector of line BC, this implies that line OC equals line OB, where O is the center of the circle, with line OC equals line OB, which equals to line OE. These line are each equals the radius r of the circle. BOC is an isosceles triangle. Label point G and join line OG. Let line BD be equals to Y and line GB be equals to X. It follows that line OD equals a -6, line OG equals a -2 and line OB equals R. From triangle BOD, use Pythagoras' theorem. The square of y equals the square of r minus the square of r minus 6, which equals to 12 times r minus 36. We call it equation 1. Also, from triangle GOB, the square of x equals the square of r minus the square of r minus 2, which equals to 4 times r minus 4. We call it equation 2. Recall that line CD equals line BD. This implies that line CD equals Y. Also, line CG equals the sum of r and r minus 2, which equals to 2 times r minus 2. Consider triangle GBC. Use Pythagoras' theorem. The square of line BC equals the sum of the square of line GC and the square of line GB. Substitute values. We have that the square of 2 times y equals 4 times the square of y, which equals to the sum of the square of 2 times a minus 2 and the square of x. Substitute equation 1 and equation 2. This implies that 4 times, in bracket, 12 times a minus 36 equals the square of 2 times a minus 2 plus 4 times a minus 4. Expand brackets. It follows that 48 times a minus 144 equals 4 times the square of r minus 8 times r plus 4 times a minus r. Combine like terms. We have the equation shown on the screen. Simplify this equation so that for times the square of r minus 53 times r plus 148 equals 0. Factorize. This implies that 4 times the square of r minus 37 times r minus 16 times r plus 148 equals to 0. Factorize completely into product of two factors. We have that the product of 4 times r minus 37 and r minus 4 equals to 0. This implies that either r minus 4 equals to 0, or 4 times r minus 37 equals to 0. It follows that r is equals to 4, or r is equals to 37 divided by 4. Consider triangle BOD. Let angle DOB be theta. Hence, y divided by r equals sine theta. Substitute values. We have that the square root of 12 times r minus 36, all divided by 1/4 of 37 equals to sine theta. Find the inverse sign of the equation. That is, theta equals the value shown on the screen. We call it equation 4. Area of the green region equals the area of sector BOD, E minus area of triangle BOD. This implies that area triangle BOD equals half the product of y and line OD, which equals to half the product of the square root of 12 times r minus 36 and r minus 6. Substitute values. We have that the product of 12 times 1/4 of 37 minus 36 and 1/4 of 37 minus 6, all divided by 2 equals 65 times the square of 3, all divided by 8. Hence, the area of triangle BOD equals the product of 65 and the square root of 3, all divided by 8 in square units. Also, area of sector BOD equals the product of theta and pi times the square of r, all divided by 360 degrees, which equals the sine inverse of the product of the square root of 12 times r minus 36 divided by 1/4 of 37 and pi times the square of 1/4 of 37. All divided by 360 degrees. This implies that the area of the green region equals the area of sector BOD E minus area of triangle BOD, which equals to the product of sine inverse of 5 times the square root of 3. All divided by 1/4 of 37 and pi times the square of 1/4 of 37. All divided by 360 degrees minus the product of 65 times the square root of 3. All divided by 8. The result is approximately equals to 37.7895 in square units to 4 decimal places. Therefore, the area of the green region equals 37.79 square units to 2 decimal places.